All right, welcome back. Hope all is well. Just going to go through the quiz review for 10.3 and 10.4 really quick. So for number one, if they ask you about the eccentricity of a hyperbola, as E increases, it becomes more and more flat. So when you get close to 1, it's very close to the curve of a regular parabola. If you increase that, it's going to flatten out. We really don't do a whole lot with eccentricity, but if they ask you that, the larger that number gets, the more flatter it gets curved. That's all you need to know. All right, here they tell us it's an ellipse, and we note that because it's addition and it equals to 1. If it's subtraction, like number 2 and equal to 1, then we know that it's a hyperbola. So given this, our center point is negative 2, 5. We have A is 6, B is 2. That allows me to find C. Then I can get my vertices once I have A, B, and since I have C, I can find my foci by adding and subtracting this to 5. The center point for this hyperbola is going to be at 4, negative 12. Again, we can get A and B, so 10 here for A, 9 for B, and then we do A squared plus C squared, so we add them, 181, so 13.45. Again, C, that allows me to find the foci, and if they ask you for the eccentricity, it's a C over A, so in this case 1.345. So again, you just want to make note of which one's first here on these so that you have the center point correctly, and then you can look at your notes to see whether it opens up, down, left, or right, or with the ellipse whether it is elongated like it's surfboard under the arm, or elongate up and down like if you're sticking it in the sand. So, all right, number 4, write the equation of the ellipse as graph. So the center point was not given. It kind of wants you to determine that on your own. So the center point is at 1, negative 2, and it's elongated this way, so x squared is going to be first. So x minus 1 squared, y plus 2 squared. We know it has to equal 1. And if we count out A is 4, so A squared 16. 3 up for B, so that's 9. And our major axes, they ask you the length of the major axes. That's the whole thing. That's 2A, so 2 times 4 is 8. Number 5, you're completing the square. So you can see I grouped the x's and grouped the y's. And the constant's already punted, so that's good. I divided the 4 out here. And then half of negative 2 is negative 1. Negative 1 squared is 1. 4 times 1 is 4. Divide the 5 out. Half of 6 is 3. 3 squared is 9. 25 times 9 is 2 1/4. So when we combine all of this, we get 100. And then we divide by 100 to get our equation. Now, if you happen to put the y squared terms first, that's okay. Once you get to this point with an ellipse, whichever number is bigger here with an ellipse would go first. With the hyperbola, the negative one goes second. But with an ellipse, whichever bottom number is larger, that's the term that goes first. So that indeed is an ellipse. All right, top of page 2. Similar idea, we group the x's and y's. Notice I put the y squared term second because it's negative. Going to complete the square just like the last example. I'm not going to talk through every step, but divided out the 9 of the x terms, divide out the 96 here with the y's. Don't forget to multiply them when you add them to the other side. And then I get 864 and divide. And so we get this result here. Again, x squared is first because it was positive. Negative y term second with the hyperbola. Number 7, they want us to graph that and get the length of the conjugate axis. Again, they did not give us the center point, so you have to know the center point's halfway between the vertices. So right here at 1, 5. It opens left and right, so x comes first, x minus 1 squared, y minus 5 squared. The distance from here to here, that is A, so that's 4 units. And so we know 4 squared is 16. We actually know C was 5. And so because we know A is 4 and C is 5, that allowed me to find B, and B is 3, which that's how we know this is 9. Conjugate axis, that's 2B, so 2 times 3 is 6. 8, the equation of ellipse. It gave us the foci here and the vertices. And so the foci is 2 units away from on each side. So we know the center point's at 6, 0. The vertices are 4 units from each side. That's fine. So I have C here and A. That allows me to find B. And since I have my center point and A and B, I can now write that equation. And this is an ellipse, so that needs to be plus. Sorry about that oversight on my part. There we go. Number 9, now we have a hyperbola back to negative here. And so we have foci plus or minus 5, so we know C is up or down. We know our center point's at 0, 3. Conjugate axis has a length of 6, so half of that is 3. So we know B is 3, C is 5, so then A has to be 4. So once we have the center point and we got A and B, we can plug it into our equation. Number 10, word problem here. So you have a semi-ellipse. So basically this whole thing's an ellipse, but you just have the top part of it because it's the opening of the cave. And the width of that cave opening is 3 feet, and the height is 2. So 3 feet all the way across, 2 feet up and down in the middle. And you want to know whether a 1 foot by 1.5 foot box, rectangular box, will fit into this opening. It doesn't matter which way you lay this. If you flip the box the other way, that'll change this number. Then this number would be 0.5, 1.5 that you plug into the equation. But I just put the box this way. So I know A is 3, B is 2. I purposely put the center point 0, 0 to make this easier to solve. And I know that X is 0.75 here for the box. So I want to make sure, and I know the height of the box is 1. So I'm going to solve for Y here. And as long as the Y value is greater than 1, the box will fit. So I put, basically what happened here is I just multiplied this by 36 to clear this out. But I could have put 0.75 in right here for X and solve. That's fine. So 4 times this number squared, moved it over, got to here. Divide by 9, take the square root. Bottom line is this. Y is 1.94. So what does that mean? If I centered the box, if I took this box and I put it right here, the X coordinate would be 0.75, probably right about there. And the height right up here is 1.94. We only need it to be a foot high to get the box in that opening, so we're good. All right, last page, system of equations. May have been a while since you've seen this, but that's okay. Let me move this out of the way here. Sorry about that. So a system of linear equations, we had to multiply both. We did that to get the y's to cancel out. So we can solve for x first. Once I have x, plug it into either equation to solve for y. So that should be review right there. Number 12. You want the rectangular coordinates given to polar, so x is r cosine theta, y is r sine theta. I'm guessing most of you did the decimals, that's fine, so you did not have to give the exact answer. I'll take the decimal. Please make a note, since this was in degrees right here, you need to be in degree mode when you do r cosine and r sine of theta. And we get to 13 here. Find the polar coordinate given the rectangular coordinate. So first thing we do, we're going to square these two to get r. Take the square root. So square root of 8, take the square root of that. And then inverse tangent y over x. We are in between 0 and 360, but here you got a positive x, negative y. So that's quadrant 4. So that's how I know that my angle has to be 315. My angle's not going to be in any of the other quadrants. So make sure you pay attention to that point so that your degree measure here matches up with the quadrant that the point is in. And then the last one, we just have a conjugate. Got to simplify this. So we multiply top and bottom by 4 plus 3i. So FOIL the top, FOIL the bottom. Remember, I squared is negative 1, so this is minus 3. This is plus 9, so we simplify here and reduce. So that's your rundown of your quiz review. If you got any questions, by all means, hit me up with an email or Google Hangout request, and we'll help you out. Thanks.